Let's do yet another video for the guitar, and let's do some more work on the tuning machine. We've got one more component to do with that. So let's make the post that comes out and tightens the string. We'll start with making a new part. And in the new part environment, I'll activate a sketch. And actually, in my view, I should be toggling some references. So toggle my planes on, and there's my new sketch. I'll make a circle about the origin, and we'll constrain that to be something like 0.375. And let's deactivate and extrude to a depth of, say, 0.575. From here, I'll jump on this face. We're going to activate a sketch, and we want this to fit into the spur gear that we've made so that they'll be locked in rotation. And I can start by drawing these nice lines. I can select my midpoint. I'll select a center line to get my midpoint there. And we'll make sure that this is vertical. Perfect. Now the gear has a tooth that comes down like this, right? So I should actually change the orientation of my lines to be this way. And so we want to make sure that there's enough gap in there. We'll maybe give it a 5 thou wider gap, right? So 0.025. And we want to connect this to an arc, and we can use a center point arc. And we'll give this arc a radius of 0.12, so we'll fit into the other groove. And now that we have that size, we'll probably want to constrain the height of this little tooth here. So we're going to say something like 0.2 divided by 2, right? And that should give us a good constraint. Now I'll grab an equal, make sure that these lines are good and equal. I'm going to draw 2 lines. Actually, I just need to draw one because I already have one that exists. So we'll mirror, and we want to mirror this figure about this vertical line. And then I'll mirror these 3 lines. And we'll mirror about this horizontal line. Now it should be an easy job of saying, we'll make these points coincident, and we're fully defined. Pretty easy. We'll deactivate our sketch, we'll do an extrude, and how about 0.25? I don't know if I recall the thickness, but I'm pretty sure that's right. So our spur gear will be sitting in here, and now, if we had the Pro version, we could probably do a threaded hole with the hole wizard, but it'll make a pretty easy work to just do something that's tappable, which I think in a lot of cases you would do anyway. So I'm going to say 0.15 for that, just a generic number. And this would be like a screw hole so that the screw would go in there and kind of hold our tuning machine together. We'll do an extrude cut. How about to the same depth? And let's sketch on this now. And we'll make a slightly larger shelf right here. We'll go with 0.5 looks good. And we'll extrude that. Right. Now, if you're astute, you may have said that this could have been taken care of with a bunch of revolves and then just an extrude cut for those teeth in there. And yes, that would be a brilliant way of doing it too. It depends on, your design intent, your workflow, and the readiness of dimensions that you have available. Let's go with 1 inch, maybe. And then why not do a revolve? So we'll sketch on that plane. I'll do a little rectangle, right? And this will, let's say, be intended to prevent a the string from slipping off the top of our post here. We'll go with coincident. And grab a dimension here of 0.1. How about 0.05? And maybe 0.7. Oh, that's way too much. Okay, 0.4, something like that. And then I do need to add a vertical relation. So vertical, right? Now we're on that axis. We'll deactivate, we'll do a revolve, and if you're astute, you could have seen that we could have done the same thing with an extrude, just sketching on the other face. And select my axis here. Well, that'll work as an axis. So well, that's still a bit big now that you look at it, right? You don't need that much, so we can even edit our sketch and take this down to something like 0.3, just a little ledge, I think is all that'll be necessary for that string. So we've got this cool little thing going on. Let's throw it in. Let's save this. So we've got this saved now, and we'll switch back to our main assembly here. All right, we're back in the assembly environment. I'll insert a design with our tuning post. I'll add 6 of those. And let's get constraining. I'll open up my new constraint dialog, and I want these faces to be coplanar, or coincident, I think is the Alibre lingo. We'll go from here to here, and from here to here, and from here to here. I can just grab one of these shoulders since they're all coincident. And we'll grab this face, and I grabbed a plane. I did not mean to grab, or even an axis, right? So we'll actually remove that and grab that face. So we're all level with the head of the guitar. Let's choose concentric. So we're able to put these posts where they belong. All right. These appear to be kind of large in comparison to some other guitars that I've seen, and I think we do have the luxury to be able to take that down without any issue. So I've got my extrusion here that we can edit the sketch of, and instead of 0.5, maybe 0.35, and that actually kind of eliminates the shelf that I wanted. So how about 0.4? That should work. Deactivate that. And everything rebuilds. Will generate to the last feature. And it appears that we don't have any errors. We'll go to the top of the tree now and edit part or subassembly. And everything is updated without error. So looks like we're doing pretty good. That looks a little bit more reasonable. And then here in our tuning machine, now it looks like I miscalculated some of my dimensions. That would actually hold quite lightly. But we can adjust that. In fact, we even can edit here and adjust our initial sketch. And this is the beauty of making assemblies, because you can go back and see how things fit and make adjustments on the fly pretty well. I think it'd be easier to visualize to reset our view in the other direction. But I am editing the wrong sketch as well. So I've got 0.12. How about 0.125? We still have some clearance. And how about 0.12 over here? A little bit too much. 0.115, a little bit better. 0.11, 0.125, 0.1125. I think that looks about right. So we just want to have enough gap that they'll slip over each other but still be constrained when we turn them. That should do it. I'll generate to last feature, and our screw would go in there. We'd probably have some kind of a washer. The other nice and luxurious thing about Alibre is we can make measurements pretty easily. So if we go back to our assembly, I can highlight this face and this face and make a measurement of 0.25. So if I edit this in a separate window, and I look at my extrusion here, and that's fine, that's just referencing the other part of the assembly. I might want to change this to 0.35. And you can see we go actually a bit above there. So again, just referencing the old assembly there, 0.3. And because it's in a rollback state, it's saying that we don't have the features to support our mates. And that's probably as expected. I'll just go ahead and save this and call it good. So we're about there. That's looking good. We may, though, just want to add in one more mate. Here and here. And we can say new constraint. Of course, it gives us an overdefined because it defaults to coincident. But I can actually change this to an angle and make the angle 0. And now we are nice and locked as we rotate, which is how we'd want it to be. So that's working pretty well. I can do the same for all of these, which I won't make you sit through. Alright, so we've got this all worked out. Next, we can edit this here, and I want to add in a hole for the string to go through. So activate a 2D sketch on that plane. You can see our origin right here. And I'll make my hole straight through this post. I don't think I snapped onto that axis, so we'll add a horizontal constraint to make sure. And then we can make this a small hole. I don't know the diameter of a guitar string off the top of my head, but maybe 0.1. And then I want to dimension this relative to the bottom of this edge. And that way, if the location of that edge changes, we'll still have a good relation there. So 0.2 might work. And then let's deactivate our sketch. We'll do an extruded cut. And this time I want to specify through all. So we've gone entirely through this post. The next thing that I would like to do is shorten this up a little bit. I think we could probably go with 0.75 inches instead of 1 inch. And so I can just walk through my tree until I find the extrusion that is related to that post. There it is. And we'll edit that and say 0.75. And now we'll generate to last feature here and get back into an isometric view. That looks a bit more like it. So we'll go to the very top and go back to our assembly environment. I think that's looking more and more reasonable as we go. So we've got that all done. Why don't we come down here and work on some pickups? This should be pretty fun. I'll start a new part. Here's the environment. I'll choose my XY plane and begin a sketch. I don't think we have a preset slot, but we don't need it, right? We'll choose a center point arc. In fact, I could do 2 center point arcs and 2 lines, and we've got a slot shape. I'll choose a horizontal relation here and here. And we'll choose a dimension of, just to get it to fit in the slot in the guitar body, we'll go with 0.395. Just to make sure, 0.395. There we go. Now it looks like I still need to add a vertical relation, probably here to here. And same from here to here. And apparently here to here, these things just keep coming out of the woodwork. All right, I think we got that nailed down. The origin can be relatively arbitrary, but if I do want it in the middle, then I can use some center lines. And I accidentally misplaced that one. I'll choose coincident from here to here and re-add my center line to the middle of there. And from there, just simply by adding vertical and equal, right? That's just one of many ways. You could have done a horizontal relation or put the origin on one of these points, whatever. From here, in fact, I don't want to dimension that, so I'll grab this middle part and this arc center, 0.995. And that should get us to fit pretty nicely in the slot. We'll deactivate the sketch, we'll do an extrude. I don't even know off the top of my head how far to extrude it, maybe 0.125. We'll save that. We'll call that pickup 1. And we can adjust the height as we go. We'll also notice that we have some fillets here. And if I highlight a fillet, I can see the radius is 50 thou. So it may be beneficial to put something like a 60 thou fillet around the base of that pickup so that it will fit in with that 50 thou in the body. We'll want to make a second pickup that's a little bit longer to accommodate this diagonal guy. And so I want to make a new part again. Here's our new part environment, same thing. I want to make 2 arcs. And since this is fresh in my mind and you've already seen me do this once, I'm sure you can confidently draw a slot on your own. This time, let's try it with tangents. I'll just go around and make sure that everything is tangent to everything else. And now, horizontal. And I don't think we need an equal because of our tangency. Of course, we can do it a little bit off-center and put the origin on 1 if we would like. So our next one, let's go from center to center here. We're going to say 2.021, and then we want a 0.395 on our pickup. We'll deactivate, and we'll run an extrude, 0.25 maybe. And this time I'll add in a fillet straight off. 0.06, how about? And we'll save that as pickup 2. Going back in our main assembly now. Insert design, pickup 1. I'll insert 2 of pickup 1s. And let's go ahead and right click, edit here. I'll choose this bottom edge, a fillet of 0.06, and close. And I love how this one updates as this one is edited. Really slick feature that you don't have to go back in the assembly environment to update the other parts. Let's grab this bottom face and this face down here. I didn't select that right, so select this bottom face, this face here, and new constraint coplanar. Here I've got this little edge right there that I can make. Oh, that's about perfect. And we should be still free to revolve around this, right? So to prevent any interferences, I can choose this little strip here, and we'll choose new constraint. Oh, but I let go of the other face, so we'll select this. And instead of coincident, we'll choose an angle of 0. And I think you can kind of see what happened. It appears as though we're fully defined just in the wrong way, right? And that's because I chose the angle of 0. So I'll go back to my last angle that I've added. I should make this 180. And there we go. We fit properly. We can do the same thing over here. Now hopefully it'll be even more straightforward. I'll select these two faces and we'll say new constraint. For some reason I let go of that other face and we'll choose concentric. We'll choose this face and this face, and we already know we want a coincident, so we'll accept that. And we're overdefined by default, but we can always change this too, and I've learned my lesson 180. So we're in there. Now how is pickup 2 going to work? Looks like we just passed through an autosave there. Let's grab pickup 2. Insert, pickup 2. We'll say new constraint, and hopefully this fits in pretty well. We'll accept that. I think we just need to choose a parallel relation, so instead of 10, we'll go with 0. Now, from there to there, we should be able to sit right in, and we have. So I think I made my pickups different distances here. Let's edit this here and go to our extrusion. We made this 0.125. How about we up that to, let's up that to 0.15. And we'll come up here and let's edit our other pickup. We'll go to our extrusion and we'll make that 0.15, I believe it was. Edit this part. Fantastic. So we fit in there pretty nicely. And how do we deal with strings? Well, maybe we can dimension this in a similar fashion to the way that we would dimension our lead nut up here. So I can edit here. There's the plane where our nut is, so I'll highlight this and activate a 2D sketch on it. Probably easier to think about it with a reset view, right? So there's our nut sticking above everything, and I want to have 6 circles. I think for design intent, I can set all of these to be horizontal. And then I can also import a reference figure, and even just that edge is fine. We'll maintain association, right? I just care about where the top of this edge is and add a horizontal relation to the very top so that the nut just has a bunch of half circles that intersect with it. Now I can choose a line, and I'll draw a line all the way across. And this is a fast and easy way to ensure that we are evenly spaced. I choose equal. Actually, I'm going to hit Control Z on that because I don't want to have overlapping lines one on top of the other. So I'm going to make sure that these are short and that these lines get progressively longer so that they'll be able to handle the resize for the equal constraint here. So we choose equal. And now they're all evenly spaced. I'm going to apply an equal relation to each hole so that each of these, and I could call them a circle at this point because that's how they exist, as a sketch, that all of these are the same size. So if I drag one, they all change. Now our frets are down here. So, it may be worth adjusting the size of our nut if we want to fine-tune the height of the string off the fretboard. I'm going to give these a fixed dimension of 0.125. How about 1/8 inch? That could be big because I think guitar strings are a lot thinner than an 1/8 inch. But this is a quick demo, and I think that these will actually change size per string. I'm not sure if they do that or not in nut design, but this should be good enough to get us the general principle of what we need, and someone who's actually making a guitar would know the answer. Let's go with, instead of to depth, we'll say mid-plane. And how about 0.25 mid-plane? There we go. Now, looks like we need even more. I thought that that was going to do it, but it apparently did not. So go to extrusion. 0.5. That should do it if we're mid-plane. Great. All right. So we've got the nut design done, I think. And then we'll come down here. Now, the neck gets a little bit wider down here than it does at top, which means our strings should get a little bit narrower as we go to the top. And we can do an in-context edit to make sure that we capture the wideness of the neck down here because we captured the wideness of the nut up here. That should be, hopefully, a pretty natural way of doing this. We'll assume for a moment that we are okay to dimension the pickups on each of these to be about the same. So coming up here, we're getting back into the assembly environment. Let's edit this first pickup. I'll right click here and say edit here. And because we edit here, we have a nice in-context edit to be able to reference the width of our neck. I'll get into a sketch on that face. All right, so let's start by projecting the width of our neck. I'll create a reference figure, and we'll go here with maintain dissociation. Now I want to draw some lines for my strings, right? So here is one line, and this would be our first pickup distance right here. Second, third, fourth, fifth, sixth, and another line. I'll add a relation, vertical, to my two ends here. And I'll make sure that we're all equal. There we are. Looks like I'm missing a vertical over here, so add that in. There we have it. So this is roughly where our pickup should be positioned. Now, I can always make these two outside lines a little bit shorter, which I actually think is a pretty rational idea, right? So I'll highlight this relation and delete that. And now we should have the flexibility to adjust this. I can also choose a coincident and make sure that we remain centered here. I will choose an equal and make sure that my two outside lines are equal to each other to preserve how centered these are. And maybe I can add a dimension, 0.025 or something like that. Now notice we've deleted a few of our equal relations, so I'll re-add that. And there we go. we should be back to even spacing. I'll make that 0.075. I imagine the lowest string would, oh boy, how about 0.1? The lowest string center would probably be right about there. So I simply add my pickup metal things that guitars have on them. I don't know what you call that, pickup sensor maybe? And we'll say equal. And I think there were probably some auto constraints that were added as I drew some of these. So I think for a lot of these, the equal constraint already exists. And yes, now they're all going to be about the same. So let's say, I don't know, a good pickup looks something like that. 0.275. Excellent. We're going to say deactivate, extrude, 0.05. That looks pretty pickup-y. I like that. So both of our pickups here are looking pretty good. And we can do an in-context edit to dimension the diagonal one, right? In context is a two-sided sword that can speed up your design process, but it can also create dependents that are unnecessary. So I'm doing this to demonstrate, the virtues and ease of in-context assembly editing, but note that if these were removed from the assembly or changed, this could destroy some of the features on the thing that we're in context editing. So it should be done with intelligence and grace. Let's edit this part now. We're going to edit here and activate a sketch. And there's the origin for that part. I think I'd like to project some reference figures of each of my pickups with maintained association. I think I'll also draw a line, and it does have the horizontal relation, so we're good there. I can draw circles now. 6 circles that I'll try not to attach to anything apart from this line. And I believe that's 6. We're going to make all these circles equal. And some of these are already equal, so I'm just going to step through any equal already exists notification in the sketch. Also, I really ought to make it equal to these ones up here. And then vertical. Well, of course, if I choose vertical, right, horizontal is this way, so vertical will probably be 10 degrees off. So if I try to set this to be vertical, yeah, it doesn't quite work. So instead, again, with in-context editing, I can choose a dimension. And we can make this something like 100 degrees because we're angled 10 degrees off. And that looks like a nice vertical line. So if I did that for each of these, with just reference lines, right? This is one of many ways to do this. You can mathematically figure out what the distancing between each of these should be and do a dimension model instead, right? Many ways to do this. We'll say actually parallel from here to here to here. And we may already have an auto constraint. This tangent doesn't look right, so we had that tangent auto constraint added that I don't think should be there. So we'll again choose parallel there. Excellent. We'll deactivate a sketch. We'll extrude. Let's do another 50 thou. And that should be our pickups. I think we're just about there. Let's squeeze in the bridge. I think we can make a generic bridge that goes in here. That's looking more and more like a guitar. Well, maybe I'll save the bridge for the next video, and we'll do the finishing touches. I won't worry about strings in this build. So maybe in the next video, we'll cover the bridge. I think my knobs fell off of my body. I think I had my knobs on in another assembly, so I'll re-add my knobs, and I think this thing looks a bit generic. I think we'll make this angled instead, and that will make it look more legit. So I think we should have a pretty darn cool guitar that will be finished in the next video. Hope this was helpful. If it was, please subscribe, and I'll see you in the next one.